Hello, and welcome to today's chemistry class for SS1. In today's class, we will be treating compounds and mixtures. But before we proceed, I would like to tickle your fancy a bit. Life is chemistry. Dilute your sorrows and evaporate your worries. Filter your mistakes and boil your pride. Then your happiness will precipitate. Enjoy the class. Let's take a quick look at the lesson objectives. At the end of this class, the students should be able to define a compound, define a mixture, differentiate between compounds and mixture. A compound is a substance which contains two or more elements chemically combined together. The key word here is chemically combined together. A compound is formed as a result of a chemical change. It is a new substance which is entirely different from the reactants that formed it. It has its own different properties from those of the elements from where it was formed. An example: water is a compound formed as a result of a chemical reaction between the component elements hydrogen and oxygen in the ratio 2:1 respectively. Now, water does not have the properties of hydrogen, neither does it have the properties of oxygen. It has its own entirely new property that is none of the two that came together to form it. Elements in a compound are chemically bonded together. The elements in any compound are always present in fixed ratios, in a particular amount of ratio. For example, hydrogen and oxygen will always combine in a ratio 2:1 to form water. A compound is formed as a result of a chemical change. The elements that combine usually lose their properties and take on new properties. A compound is a pure substance because it cannot be separated into more than one component by physical methods. A mixture, on the other hand, consists of more than one element or compound. The components of a mixture can be separated by physical methods. It simply means the components are not chemically combined. They can be separated by simple physical processes. Now let's take a look at this slide and see the basic difference. Look at pure substances. You can have elements, they are pure. The elements can combine with themselves. Two different elements can combine with themselves to form a compound. They will still be pure substances because they are chemically mixed. And the elements, once they chemically mix, they lose their initial properties and then form a new property of the new compound. Now, mixtures. Mixtures can be homogeneous or heterogeneous. Homogeneous simply means the mixtures mix so smoothly that you don't even see the separate particles. A good example is when you have milk in water. The milk will mix with the water so finely that it will be homogeneous. You will not see the separate particles of the milk. Now, for heterogeneous, the mixtures do not mix completely. In that, imagine you having rice and beans or sand and water. You can easily see the sand. You can easily see the rice or the beans. Unlike the analogy of the milk, that will mix completely, you will not see. So any mixture that mixes completely, that you don't see the particles separately from themselves, we call it a homogeneous mixture. While anyone that mixes in a way that you can still see the different particles that came together to form it, that kind of mixture is called a heterogeneous mixture. So let's take a good look at the properties of mixtures and compounds. A mixture, it may be homogeneous or heterogeneous. We just explained that in the last slide. But a compound is always homogeneous. The constituents of a mixture are not chemically bonded together and can therefore be easily separated and recovered by physical means. Meanwhile, for the compound, the component elements are chemically bound together and cannot be separated by physical means. The mixture, the constituents are added together in any ratio by mass. Hence, a mixture cannot be represented by a chemical formula. But a compound, the components are present in a fixed ratio by mass and can always be represented by a chemical formula. For the mixture, the properties of mixtures are the sum of those of its individual constituents. As a good example, if you taste salt, you have a salty taste. If you taste sugar, you have a sugary taste. But if you mix them together and taste them, you are going to have a sum of the two tastes together. You will have a taste that is not salty, that is not sugary, that is just in between, because both of them are mixed and contributing to what you are tasting. While the properties of a compound differ from those of its component elements. So, to give you further illustration, look at the mixture by your left and the compound by your right. You will see we have oxygen and hydrogen molecules. They are floating on their own separately. They are just mixtures. But when they now become a compound, they will chemically come together. You can see how the hydrogen and oxygen have now bonded with themselves to form water molecules. What we have been saying all this while is that after this new formation of the compound, the hydrogen and oxygen will lose all their properties as individual molecules and will pick up a new property of the new compound which they have just formed. So let's now take a look at atomicity, which we have described as the number of atoms in a molecule of a substance. A good example, atomicity of helium is 1 because it comes as just one atom, while the atomicity of nitrogen is 2 because it comes as 2 atoms bonded together. The atomicity of water, H2O, is 3 because it has 3 molecules, 2 of hydrogen and 1 of oxygen. Summary. In this lesson, we have learnt about compounds, classes of compounds, mixtures, and types of mixtures. Let's now take a quick assessment to see how far we have learnt. Question 1. The ionic compound containing Fe3+ and SO4 would have the formula. Question 2. Chemical formula of zinc hydroxide is. Question 3. What is the atomicity of H2SO4? With this, my dear students, we have come to the end of this lesson. Thanks for watching and see you in the next class.